Every single science textbook you have ever opened shows our galaxy as a perfectly flat, beautiful spinning plate. That picture in your head is completely wrong, because right now the outer edges of our Milky Way are twisting and bending like a piece of melted plastic left on a hot stove. One side is curling upward thousands of light years into deep space, while the opposite side is sagging downward into the darkness. We are riding inside a giant, warped cosmic wave that is wobbling through space this very second. If you love discovering the real, hidden truths about our universe without any scientific hype or boring lectures, hit the subscribe button right now. Join our community of curious thinkers who want to see deep space as it actually is. For almost 100 years, human beings were completely convinced that our home in the stars was neat, tidy, and symmetrical. When you look at classic spiral galaxies through a backyard telescope, like the famous Pinwheel Galaxy or the Whirlpool Galaxy, they look like glowing silver frisbees. Early astronomers assumed that gravity would always pull a spinning collection of stars into a smooth, thin, flat circle. It made total sense on paper because when you spin a ball of soft pizza dough in the air, the edges naturally flatten out evenly in every direction. The centrifugal force from the spin pushes everything outward, while gravity pulls everything inward toward the middle. When those two forces balance out, you are supposed to get a flat, balanced disk. For generations, scientists believed our Milky Way was the ultimate example of this perfect cosmic balance. They drew diagrams in astronomy books showing our sun sitting on a smooth, level plane, orbiting the center like a marble, rolling around a flat wooden table. Nobody questioned this basic idea because all our physical models said a galaxy of our size had to be flat. The biggest problem with figuring out the true shape of our galaxy is our location. Imagine you are standing deep in the middle of an enormous dark forest, filled with hundreds of billions of tall trees. If someone asked you to draw an exact map of the entire forest from above, you would have a terrible time trying to do it. You cannot fly up into the air to look down at the trees, and your view in every direction is blocked by thick wood, tangled branches, and floating leaves. You can only see the trees that are right next to you, while everything behind them is hidden behind a wall of shadows. That is our exact situation inside the Milky Way galaxy today. Our solar system sits about 26,000 light years away from the bright galactic center, tucked deep inside one of the spiral arms called the Orion Spur. When we look out into the night sky, we are looking through thousands of light years of thick cosmic dust, glowing gas clouds, and blinding fields of billions of stars. For generations, scientists could only guess what our galaxy looked like from the outside by looking at other distant galaxies and hoping we were just like them. We took pictures of beautiful spiral galaxies millions of light years away and simply assumed that our own Milky Way was a twin of those perfect flat shapes. Back in the late 1700s, a brilliant astronomer named William Herschel tried to solve this mystery by counting every single star he could see. He built giant telescopes out of metal and wood, spending endless freezing nights staring into the dark sky from his home in England. He divided the night sky into hundreds of small sections and patiently counted every single tiny point of light in every direction. After years of exhausting work, Herschel drew a rough map that made the Milky Way look like a lumpy, flattened cloud of stars, with our sun sitting right near the middle. Herschel did the absolute best job he could with the limited tools of his time, but he was completely tricked by cosmic dust. He did not know that thick clouds of dark dust particles were floating between the stars, blocking the faint light from the distant edges of the galaxy. Because the dust blocked his view equally in almost every direction, it made it look like the stars ended just a short distance away from Earth. This optical illusion made him believe the galaxy was small, flat, and that human beings were sitting right at the very center of everything. More than a century later, in the early 1900s, an astronomer named Harlow Shapley found a clever way to see past some of this cosmic fog. Instead of counting individual faint stars near the galactic disk, he studied giant spheres of ancient stars called globular clusters that hover high above and below our galaxy. Shapley realized that these massive star clusters were not centered around our sun at all. They were clearly gathered around a distant point tens of thousands of light years away from us, pointing toward the bright constellation of Sagittarius. This discovery proved once and for all that we were not at the center of the universe, but rather living out in the quiet suburbs of a giant cosmic city. Yet even with this massive breakthrough, Shapley and everyone who followed him still believed the outer suburbs of the galaxy were completely flat and level. The problem with visible light is that it gets scattered and swallowed up by tiny dust grains floating in space. Just like a thick fog on a highway blocks the headlights of oncoming cars, interstellar dust creates huge dark patches in the night sky called the Great Rift, hiding the true structure of our galaxy from our eyes. Did you ever realize that we are trapped inside our own galaxy, unable to see the big picture, just like someone lost in a giant forest of stars? Drop a comment below with your thoughts, and tap the like button if you love learning about how scientists unlock the secrets of deep space. To break through this cosmic wall of dust, Astronomers in the middle of the 20th century had to invent a completely new way of seeing the universe. They stopped looking only with regular glass lenses and started building giant radio telescopes that could listen to the sky. Light waves are very small and get easily blocked by microscopic dust particles, but radio waves have much longer wavelengths. These long radio waves can pass right through dense clouds of cosmic dust and gas without getting scattered or absorbed, traveling across the entire galaxy untouched. During the 1940s, a young Dutch astronomer named Hendrik van de Hulst made a groundbreaking mathematical prediction. He calculated that cold hydrogen gas floating in the vacuum of deep space should naturally emit a very faint, specific radio signal with a wavelength of 21 centimeters. Hydrogen is the most common element in the entire universe, making up the vast majority of all the gas floating between the stars in the Milky Way. If astronomers could build radio dishes sensitive enough to detect this 21 centimeter hum, they could map the entire outline of our galaxy from the inside out. In 1951, physics researchers at Harvard University successfully detected this faint hydrogen radio signal for the very first time. Soon after, radio astronomy teams in the Netherlands and Australia began using massive metal dishes to scan every inch of the northern and southern skies. By measuring the radio waves coming from a neutral hydrogen gas, they were hoping to confirm the neat, flat spiral arms that everyone had predicted for decades. They expected to see a smooth, flat disk of cold gas spinning gracefully around the bright galactic core like water around a drain. What they actually found on their paper chart recorders shocked the entire astronomical community to its core. The cold hydrogen gas at the outer edges of the Milky Way was not staying in a flat line at all. It was twisted into an unmistakable, gigantic S-shaped curve. On one side of the galaxy, in the northern sky, the hydrogen gas was curving thousands of light years above the expected flat plane. On the exact opposite side, in the southern sky, the gas was drooping thousands of light years below the level plane, into the deep cosmic void. Instead of a flat dinner plate, the gas map of our galaxy looked like a bent vinyl record that had been left sitting in the hot sun. The bend did not start in the middle where our sun lives, but became wildly extreme the farther out you traveled toward the distant perimeter. When these radio maps were published in the late 1950s, most mainstream astrophysicists refused to accept that the actual galaxy was bent. They argued that hydrogen gas is extremely light, flimsy, and easy to push around by random cosmic forces. A strong magnetic field or a sudden burst of energy from exploding supernova stars could easily push a lightweight cloud of hydrogen gas out of alignment. Gas is like light smoke drifting in the wind. A small gust can blow smoke into all kinds of strange, curly shapes without moving anything heavy. Stars, on the other hand, are completely different beasts. A star like our sun is a gigantic ball of super-dense plasma that weighs more than 300,000 times the mass of the entire Earth. Massive stars carry huge amounts of momentum and are bound together by the relentless, heavy grip of gravity. The established scientific theory stated that even if the light hydrogen gas was ruffled and messy around the edges, the heavy stars must still form a rigid, flat, and stable disk. For more than 50 years, this remained the dominant view in textbook astronomy. The gas is warped, but the stars are flat. Nobody could prove whether the stars were actually warped along with the gas, because measuring exact distances to individual stars across the vast expanse of the Milky Way was nearly impossible with 20th century technology. If you look at a faint point of light in the night sky, you have no easy way of knowing what you are looking at. It could be a tiny dim dwarf star sitting very close to our solar system, or it could be a monster supergiant star shining millions of times brighter, sitting on the far side of the galaxy. Without knowing the precise distance to each star, you cannot place them on a three-dimensional grid. And without a true three-dimensional grid, the real shape of our stellar disk remained an unsolved scientific debate for decades. Do you think it makes sense that scientists spent 50 years arguing about whether the stars were bent along with the gas? Let me know your opinion in the comments below, and do not forget to subscribe to help our channel bring you more incredible science stories. To finally settle the debate between the flat star theory and the warped disk reality, astronomers needed a very special kind of cosmic measuring tape. Fortunately, the universe had already provided one in the form of rare, pulsating giant stars known as Cepheid variables. Cepheid variables are massive, supergiant stars that can be thousands of times larger and up to 100,000 times brighter than our own sun. They are not calm and steady like our sun. Instead, they slowly breathe in and out, swelling up to enormous sizes and then shrinking back down in a rhythmic cycle. As a Cepheid star expands, its outer layers cool down and become dim. As it contracts, the pressure builds up, heating the core and causing the star to blaze with intense brightness. This pulsing pattern repeats like clockwork over regular periods of days, weeks, or months. Back in 1912, a brilliant astronomer working at the Harvard College Observatory named Henrietta Swan Leavitt made a discovery that changed human history. While studying thousands of variable stars in photographic plates, she noticed a direct relationship between the pulsing speed of a Cepheid and its true intrinsic brightness. Leavitt discovered that the longer a Cepheid star takes to complete one full breathing cycle, the more light it actually produces in real life. A slow-pulsing Cepheid is an absolute cosmic monster blasting out immense power, while a fast-pulsing Cepheid is smaller and less luminous. This simple relationship gave astronomers what is known in physics as a standard candle. If you know the exact wattage of a light bulb at its source, you can easily calculate its exact distance simply by measuring how dim it looks to your eyes from where you are standing. If you see a 50-watt light bulb that looks tiny and faint in the distance, you can use the basic inverse square law of light to calculate exactly how many miles down the dark road that light bulb is sitting. By finding Cepheid variable stars scattered across our galaxy, astronomers finally had the perfect tool to build a real map. Cepheid stars are especially useful for this task because they are young, massive stars that live short, energetic lives of only a few tens of millions of years. Because they die young, they never have enough time to drift far away from the stellar nurseries where they were born out of the galactic gas disk. This meant that if you could find the exact three-dimensional positions of thousands of Cepheids across the Milky Way, their locations would show the exact current shape of the stellar disk with zero guesswork. In 2019, an international team of scientists from Warsaw University decided to build this ultimate map using the optical gravitational lensing experiment, known as the OGLE project. For years, the OGLE project used a powerful dedicated telescope located under the crystal-clear dry skies of the Las Campanas Observatory in the Atacama Desert of Chile. Night after night, the telescope took millions of digital pictures of the Milky Way, tracking the changing brightness of billions of points of light. The Polish research team painstakingly identified and tracked more than 2,400 individual Cepheid variable stars scattered across the entire breadth of our galaxy. They used sensitive infrared sensors that could see straight through the thickest curtains of interstellar dust. When the scientists finished calculating the precise distances to all 2,400 stars and loaded their coordinates into a supercomputer to plot the first true three-dimensional map of our galaxy, the result completely destroyed the old flat disk model once and for all. The heavy, massive stars were not sitting on a flat plane. The stars followed the exact same dramatic S-shaped curve as the hydrogen gas discovered decades earlier. The scientific debate was officially over. The stellar disk of the Milky Way is warped, twisted, and flared out of shape. The scale of this distortion is so gigantic that it defies human imagination. Near our solar system, the galactic disk is relatively flat and well-behaved, which is why ancient astronomers looking up at the sky never noticed the bend from our local neighborhood. If you could travel back in time and tell early astronomers that their flat galaxy was actually twisted like a broken wheel, how do you think they would have reacted? Share your thoughts in the comments below, and hit that subscribe button to stay updated with every new breakthrough in astronomy. As you travel farther away from the bright galactic center, past 50,000 light-years into the outer rim, the disk begins to violently flare and bend away from the flat plane. On one side of the galaxy, the disk curves upward into deep space by more than 4,000 light-years above the central line. On the exact opposite side, the edge of the disk plunges downward by more than 5,000 light-years below the galactic plane. To understand how massive that bend really is, consider the fact that the entire thickness of our galaxy near the Sun is only about 1,000 light-years. That means the outer edge of our galaxy is bent out of place by a distance that is 4 to 5 times greater than the entire thickness of the disk itself. If you held a large plastic dinner plate in your hands and twisted both edges with pliers until it formed an S shape, that is what our galactic home looks like from deep space. Even more surprising was the discovery that the disk is flared. In the center of the galaxy, the stars are packed into a relatively thin layer. But as you move out toward the warped edges, the disk gets dramatically thicker and wider, spreading stars out across thousands of light-years of vertical space. This monumental discovery proved that the stars were warped, but it instantly raised a terrifying new question. What kind of unbelievable cosmic force could possibly be powerful enough to bend a giant disk made of hundreds of billions of stars and weighing as much as 1 trillion suns? Gravity naturally pulls massive spinning objects into smooth, balanced, flat shapes over time. For a galaxy as large and heavy as the Milky Way to stay twisted, something massive must be actively pushing, pulling, or torquing the disk from the outside. To find out what was causing this extreme bend, scientists needed more than just a still photograph showing where the stars are sitting right now. They needed to see how the stars are moving through space over time. That is where the European Space Agency stepped in with one of the most advanced and ambitious scientific instruments ever launched into space, the Gaia spacecraft. Launched in late 2013 to orbit at a stable gravitational point called Lagrange Point 2, 1 million miles away from Earth, Gaia had a mission to create the most precise three-dimensional moving map of the universe ever attempted. Gaia is equipped with the largest digital camera ever flown in space, capable of measuring the positions, distances, and real-time motions of nearly 2 billion individual stars with mind-boggling precision. The telescope is so sharp and sensitive that it could measure the thickness of a single human hair sitting on top of a building hundreds of miles away. It did not just take static snapshots. It watched stars drift across the sky year after year, tracking their speeds and orbital paths in 3 dimensions. In 2020, a team of astrophysicists led by Eloisa Poggio at the Turin Astrophysical Observatory analyzed the precise 3-dimensional motions of 12 million giant stars observed by the Gaia telescope. They wanted to solve a fundamental physics question. Is the warp in our galaxy a frozen, static shape like a piece of bent metal, or is the warp actively moving and rippling through space like a flag flapping in the wind? What they discovered sent shockwaves through the astrophysics community. The warp of the Milky Way is not frozen in place at all. The entire warp is moving, rotating, and wobbling through space in real time. As individual stars travel along their normal orbits around the galactic core, the giant wave of the warp itself is slowly rotating around the center of the galaxy. This slow, wobbling rotation of a spinning system is known in physics as precession. If you have ever spun a heavy toy top on a smooth wooden table, you have seen precession happen with your own eyes. When the top spins very fast, its axis stands straight up and down, perfectly balanced and steady. As the top begins to lose energy, or if you gently tap it with the tip of your finger, the axis begins to lean over to one side. Instead of falling down immediately, the leaning top begins to trace a slow, wide circle in the air as it continues to spin. That circular wobble is precession. The outer edges of our entire galaxy are doing that exact same wobbling dance on a scale that spans tens of thousands of light years across the cosmic void. Using the ultra-precise velocity data from the Gaia satellite, the researchers were able to measure the exact speed of this galactic wobble for the very first time in human history. They calculated that the warp wave travels all the way around the Milky Way, once every 600 to 700 million years. While that sounds like an unimaginably long time compared to a human lifespan, in cosmic terms, it is blisteringly fast. For comparison, our own sun takes about 230 million years to complete a single orbital trip around the galactic center. The stars sitting out in the distant, warped edges of the galaxy take much longer, taking hundreds of millions of years to make a single circle. The fact that the warp wave rotates around the galaxy in just 600 to 700 million years means the wave is moving much faster than the individual stars orbiting within the disk. This critical speed measurement proved something vital to astrophysicists. A fast-moving wave cannot be an ancient permanent structure that has been sitting around since the Milky Way first formed 13 billion years ago. If the warp were that old, the natural gravitational forces within the galaxy would have smeared it out, dampened the ripples, and flattened the disk back into a smooth shape billions of years ago. The warp must be young, fresh, and actively driven by a powerful external force that recently disturbed our galaxy. Imagine throwing a heavy brick into a calm, smooth swimming pool. The moment the brick hits the water tall, sharp ripples race across the surface in expanding circles. If you walk into the backyard and see those sharp ripples bouncing off the walls, you know the brick fell into the pool just a few moments ago. The Milky Way is currently covered in sharp cosmic ripples, meaning our galaxy was recently struck by a massive cosmic bullet. Can you picture our entire galaxy wobbling like a giant spinning top as it hurtles through the darkness of space? Drop a comment below with your reaction. And please like and subscribe to join our growing community of space explorers. So what was the giant cosmic brick that hit our galaxy and set off these massive ripples? Astronomers turned their telescopes toward the space immediately surrounding the Milky Way to look for the culprit, and they found a bruised, battered victim, the Sagittarius Dwarf Galaxy. The Sagittarius Dwarf Galaxy is a small, miniature galaxy containing only a few tens of millions of stars, compared to the hundreds of billions of stars inside our giant Milky Way. It is caught in our powerful gravitational trap, orbiting us like a moth trapped around a blazing light bulb. Over billions of years, the intense gravity of the Milky Way has been slowly tearing the Sagittarius Dwarf Galaxy to pieces, stripping away its gas and pulling its stars out into long, stretching stellar ribbons that wrap around our galaxy. Computer simulations run on advanced supercomputers have shown that the Sagittarius Dwarf Galaxy has an orbit that forces it to plunge straight through the thick disk of the Milky Way again and again. Every time this small galaxy smashes through our disk, it acts like a heavy bowling ball dropped onto a tightly stretched rubber trampoline. The Milky Way is so massive that it easily survives the physical collision, but the gravitational shockwave sends massive vibrations rippling across our entire stellar disk. Astrophysicists estimate that the Sagittarius Dwarf Galaxy smashed through our disk about 500 or 600 million years ago, passing right through our neighborhood of space. As it punched through the disk, its gravitational pull tugged billions of our stars out of their flat orbits. When the intruder passed out the other side, the stretched disk bounced back, overshot its original position, and began to oscillate up and down like a plucked guitar string. That single impact set off the massive warp wave that we are still measuring with the Gaia satellite today. The Sagittarius Dwarf Galaxy is currently circling around for another pass, acting like a cosmic hammer that keeps ringing our galaxy like a giant metal bell. However, some scientists believe that the Sagittarius Dwarf Galaxy might not be massive enough on its own to create such a huge, violent twist. They suspect there is another, much darker suspect lurking in the shadows, the mysterious halo of dark matter. Astrophysicists know that every large galaxy in the universe is wrapped inside an enormous, invisible cloud of dark matter that extends far beyond the visible stars. Dark matter does not emit, reflect, or absorb any light, but its heavy mass provides the primary gravitational glue that holds galaxies together. Recent scientific models suggest that the giant dark matter halo surrounding our Milky Way is not aligned with our flat disk of stars. Instead, the invisible dark matter cloud appears to be tilted at an angle of roughly 25 degrees relative to the disk. Imagine taking a spinning dinner plate and placing it inside a giant, invisible, tilted beach ball. If the heavy dark matter halo is tilted, its massive gravitational pull is constantly pulling unevenly on the edges of our stellar disk. One side of the disk is pulled upward toward the heavy part of the tilted dark matter halo, while the other side is pulled downward in the opposite direction. This constant, uneven gravitational pull creates a permanent cosmic torque, twisting the outer edges into an S-curve and keeping the warp alive for billions of years. When you combine the violent, repeated impacts of crashing dwarf galaxies with the relentless, silent twisting force of a tilted dark matter halo, our galaxy never had a chance to stay flat. It is constantly being stretched, battered, and bent by invisible forces that dwarf our entire solar system. Does the idea of an invisible tilted cloud of dark matter bending our entire galaxy sound like science fiction to you? Or does it show how strange the universe really is? Share your thoughts below and hit the subscribe button so you never miss our deep dives into the cosmos. The warping of our galaxy is not just something happening at the faraway edges. The ripples of this distortion are traveling right through our own local neighborhood. In 2020, astronomers at Harvard University made a shocking discovery sitting right in our backyard, the Radcliffe Wave. The Radcliffe Wave is an enormous connected ribbon of dense gas and baby stars that stretches for 9,000 light-years through our local spiral arm of the galaxy. It is 400 light-years wide and rises hundreds of light-years above and below the flat plane of the disk. For more than a century, astronomers had looked at famous star-forming regions like the Orion Nebula, the Taurus molecular cloud, and the Perseus cloud as separate, isolated blobs of gas floating in space. We were sitting too close inside the forest to see that they were all connected. When researchers analyzed the Gaia satellite data in full 3 dimensions, they were stunned to find that all these famous stellar nurseries form one single, gigantic, continuous wave that undulates through space like a massive cosmic snake. Even more incredible, recent measurements from 2024 have confirmed that the entire 9,000 light-year Radcliffe Wave is actively moving. The gas clouds and newborn stars inside the wave are bobbing up and down through space like corks floating on the surface of choppy ocean waves. Our own sun is currently drifting right through this vibrating wave of gas and stars as we speak. As our solar system orbits the center of the galaxy at 500,000 miles per hour, we do not travel in a straight, level line. Our sun bobs up and down through the galactic plane like a wooden horse on a giant carousel, crossing through the densest part of the disk once every 30 to 33 million years. We are actively surfing on the cosmic ripples created by collisions that happened hundreds of millions of years ago. This constant vertical bobbing motion changes how we think about the history of life on our own planet. When our solar system passes through the dense midplane of the galaxy, we are exposed to stronger gravitational forces from passing stars and giant molecular clouds. Some scientists have proposed that these periodic dips through the dense galactic plane could gravitationally disturb the icy comets resting in the distant Oort cloud, sending a shower of deadly comets flying into the inner solar system and triggering periodic mass extinction events on Earth. While our planet is completely safe today, knowing that our galaxy is a vibrating, dynamic, and constantly changing environment changes everything about our place in the universe. We do not live in a quiet, frozen museum of stars. We live inside a living, breathing, ringing instrument that reacts to every collision in deep space. Looking into the distant future, the shape of our galaxy is destined to undergo an even more violent transformation. The giant Andromeda galaxy, which is even larger and more massive than the Milky Way, is currently hurtling directly toward us at 250,000 miles per hour. In about 4.5 billion years, the Milky Way and Andromeda will begin an epic gravitational collision. The delicate spiral arms, the elegant Radcliffe Wave, and the warped outer edges will be completely torn apart by massive tidal forces, stretching trillions of stars into long, glowing tails across the darkness. Over billions of years of cosmic dance, gravity will smooth out the chaos, merging both spiral galaxies into one gigantic, smooth, football-shaped elliptical galaxy that astronomers have nicknamed Milky. The warps, the ripples, and the beautiful spiral patterns will be erased forever, swallowed up by a massive, calm sphere of aging stars. We happen to be living during a brief golden cosmic era when our galaxy has a wild, dynamic, and twisted personality. The next time you step outside on a clear, dark night and look up at the glowing band of the Milky Way stretching across the sky, remember the hidden truth. That soft river of light is not a flat, peaceful road through the heavens. You are looking at the edge of a giant, twisted wave made of hundreds of billions of suns, rushing through the dark, rippling with ancient collisions, and wobbling like a spinning top against the infinite void of space. If you enjoyed discovering the real, twisted shape of our home galaxy, please hit the subscribe button, turn on all notifications, drop a comment below letting us know whether you think dwarf galaxies or dark matter are more responsible for the warp, and share this video with a friend who loves space mysteries. Thank you so much for watching, and keep looking up at the wonders of our universe.